Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one question, completing the square, lost more marks than any other quadratic question on last year's AQA higher paper. Students knew the formula, but sign and scaling slips killed marks. If you can learn one tidy routine today, that's a reliable chunk of marks on exam day. Sound familiar?
Wait, is completing the square the same as using the quadratic formula? I always get mixed up under time pressure.
Good question, Maya. They're different tools. Completing the square rewrites the quadratic into a neat vertex form and shows the turning point directly. The quadratic formula solves for roots. Today, we'll focus on a repeatable routine for completing the square, so you can sketch graphs, find maxima or minima, and pick up method marks, even if you don't finish the algebra. Here's what you'll learn in the next 11 minutes. A step-by-step routine for a not equal to 1 and a equals to 1, a worked 4-mark exam example with exact mark allocations, and a 2-second check to catch the usual errors.
The concept. Start simple. Suppose we have x squared plus 6x plus 5, x squared plus 6x plus 5. That's the a equals 1 case. The aim is to write it as x plus h squared plus k. That's called vertex form, and it shows the turning point at minus hk. Why do we add and subtract a number? Because we want a perfect square trinomial. A square bracket we can write as x plus something squared. Here's the routine. Take the linear coefficient, half it, square it, then add and subtract that square inside the expression. For x squared plus 6x plus 5, half of 6 is 3, square is 9. So we write x squared plus 6x plus 9 minus 9 plus 5. The first 3 terms make x plus 3 squared, and the rest combine to give the constant. Minus 9 plus 5 equals minus 4. So x squared plus 6x plus 5 equals x plus 3 squared minus 4. That's the vertex form. The turning point is at minus 3 minus 4. Let that sink in.
So the half and square trick is just a way to force a perfect square. I can do that on paper.
Exactly. Now the slightly more fiddly case, a not equal to 1. Example, 2x squared plus 8x plus 5. If we tried the same half the linear coefficient inside as is, we get the scale wrong. So first factor the leading coefficient out of the x squared and x terms only. 2x squared plus 8x plus 5 equals 2 times x squared plus 4x plus 5. Now complete the square inside the bracket. Half of 4 is 2, square is 4, so add and subtract 4 inside. 2 times x squared plus 4x plus 4 minus 4 plus 5. The first 3 inside make x plus 2 squared. Keep track of the scale. The minus 4 inside is multiplied by 2 outside, so it becomes minus 8. So we have 2 times x plus 2 squared minus 8 plus 5, which simplifies to 2 times x plus 2 squared minus 3. So the vertex form is 2 times x plus 2 squared minus 3, and the turning point is at minus 2 minus 3.
Pause for the y. We add and subtract the same number, so the expression is unchanged algebraically. We factor a to keep the perfect square structure inside the bracket. Always watch that subtract term. It's scaled by a. That scaling is the number that trips up many students in pressure conditions. Worked exam example. Write 2x squared plus 8x plus 5 in the form 2 into x plus a all squared plus b. Marks 4. M1 for factorising 2 from the first 2 terms, M1 for completing the square inside the bracket, M1 for simplifying constants correctly, A1 for the final correct form. Let's apply the method and speak the examiner's language as we go. Step 1. Factor 2 from x squared and 8x. Write 2 bracket x squared plus 4x plus 5. That collects you M1. Step 2. Complete the square inside the bracket. Write 2 bracket x squared plus 4x plus 4 minus 4 plus 5. Then 2 bracket x plus 2 squared minus 4 plus 5. That's your second M1 for the correct method. Step 3. Expand the constants.
2 bracket x plus 2 squared minus 8 plus 5 equals 2 bracket x plus 2 squared minus 3. If you showed the arithmetic minus 8 plus 5 equals minus 3, you collect the third method mark and the accuracy mark for the final correct expression. Write it all down. The examiner wants to see each algebra step. Marks are there for the taking.
If I run out of time and can't finish, what should I make sure I've written to get those method marks?
Great question. Exam technique: always write the factorization step first. That often nets M1. Next, write the expression with the bracket plus the square term you're adding. Even if you don't simplify the constants, you've shown the method. For instance, if you had 2 times x squared plus 4x plus 4 plus 5 written, the marker sees you understand completing the square and awards method marks. If you don't reach the final simplified form, a clear annotation like complete square inside bracket helps the examiner award marks. And crucially, label your final line clearly so marks can be allocated without hunting for your working.
The quick win. A 2-second check and a memory trick you can use under timed conditions. Memory trick. Half, square, divide. Take half the linear coefficient, square it, and if a doesn't equal 1, remember to divide by the leading coefficient only after you factor it out. 2-second check. Expand your vertex form quickly to check constants. For example, if you found 2 times x plus 2 squared minus 3, expand 2 times x squared plus 4x plus 4 minus 3 to check you return to 2x squared plus 8x plus 5. If the constant doesn't match, you know a sign or scaling slip happened. This check takes 10 seconds and catches most errors.
I like that. Check by expanding back. Feels safe in an exam. Common mistakes and quick fixes. Number 1, forgetting to divide the added square by a, or equivalently, not factoring a out first. Fix: always factor a from the x squared and x terms before you complete the square. Number 2, sign slips when halving the linear term. Fix: write the half explicitly as b over 2, or show the arithmetic. 4, half is 2, square is 4. If you follow the small checklist, factor, half, square, add, subtract, scale the subtraction by a, you rescue marks quickly. Write it down, don't just think it.
If marking, we award method marks for correct algebraic steps, even if the final arithmetic is off. So neat, labelled working matters more than mental shortcuts that aren't shown on paper.
Before we close, a very short checklist to keep on your exam desk. 1. Factor a from the x squared and x terms. 2. Half the linear coefficient inside the bracket and square it. 3. Add and subtract that square inside the bracket. 4. Multiply the subtracted term by a when you take it out. 5. Simplify constants and box the final vertex form. Stick to those 5 steps and you'll stop losing easy marks.
That feels manageable. I can practice that 5-step checklist tonight.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.